Well, in this screencast, we broaden greatly the classes of series that we are able to analyze for convergence or divergence, because in this screencast, we decide how to compare two series. Maybe we don't know anything about a particular series, but maybe we know how it relates to something else that we do know a lot about. And so that's what this is about. In this screencast, we're going to talk about two comparison tests. One is called the direct comparison test. The other one will be called the limit comparison test. The direct comparison test says, suppose that 0 is less than or equal to S sub n, which is less than or equal to A sub n, which is less than or equal to B sub n, for sufficiently large n. What does that mean? It means that maybe the first 1,000 terms don't do this, but after a while, after the first 1,000 terms or the first 1,000,000 terms or whatever, A sub n is trapped between S sub n and B sub n, and they're all non-negative. So this is our series. Sometimes we're going to be able to compare it to a series that's bigger. And sometimes we're going to be able to compare it to a series that's smaller. But we know that this is the way this runs. If the sum to infinity of the B sub n's converges, then the sum of the A sub n's also converges. Why? Because if you add up terms that are bigger and they settle down to some number, then adding things that are less than that can't go off to infinity. By the same token, if the sum of the S sub n's diverges, then the sum of the A sub n's diverges. Why? Because if we add up smaller numbers and that sum goes off to infinity, then adding up bigger numbers has to go off to infinity. That's the theory here. So a real quick example just to illustrate. Does the sum 3 to the n over 4 to the n plus 5, as n goes from 1 to infinity, converge? Well, we can compare this to something that we know about. We know that 3 to the n over 4 to the n plus 5 is less than 3 to the n over 4 to the n because they have the same numerators, but this denominator is bigger. What do we know about this? We know that this is the sum of 3/4 to the n, and that's a geometric series. This is 3/4, 9/16, and so on. And r is 3/4, which has an absolute value less than 1. Absolute value of r is 3/4, which is less than 1. And so this series converges, and these terms are less than these terms. So this series converges. That is a direct comparison test. The other test we want to talk about is the limit comparison test. The limit comparison test I sometimes refer to as the law of looks like, because we decide that if we squint near infinity, it's basically this other thing. And so we can talk about it as if it were the other thing. We let the sequences A sub n and B sub n be sequences of positive numbers. Still no negative numbers, not till next week. If the limit as n approaches infinity of A sub n over B sub n is any number that isn't 0, then both series converge or both series diverge. Why? Well, it comes down to remembering what this means. If you take the limit at infinity of one over the other, and you get any number that isn't 0, it means that both series grow at the same rate. If we think about their associated functions would grow at the same rate. And if they grow at the same rate, then whatever the one series does, the other series has to do. They can't have one of them converge and one of them diverge if they're growing at the same rate. So in this scenario, the A sub n is the series that we want to know about, and the B sub n is something that looks just like it. So, for example, does the sum from 1 to infinity of n squared over n to the fourth minus n minus 1 converge? So how do we do this? Well, we take our thumb and we kind of cover up everything but the highest power. And we say, what's this? This is 1 over n squared. And so we pretend that this series is 1 over n squared. We will compare with the sum of the 1 over n squareds. Because we know what this series does. This is a p series. This series converges. It's a p series with p greater than 1. So then it's just up to us to show that the limit as n approaches infinity of our series over the series we know about is any number that isn't 0. So my algebra is not the best, but I know that we multiply by a reciprocal here. And I know that we only consider the highest powers of n here. And this is a number that isn't 0. And because this is a number that isn't 0, whatever this series does, that series does. This series converges. That series converges. And that's how we use the limit comparison test. There will be another screencast with examples, but this is the theory.